What do we mean by solving linear equations in one variable? Is it important for us to know what the word solve means? When we're given a problem to work and the instructions say to solve and check, do we know what we're supposed to do? Let's look at a typical problem. Solve and check. 3x plus 7 equals 2x minus 1. To solve an equation means to find the value of the variable, which when substituted into the equation gives the result of the same number on both sides of the equation. For this equation, the solution set is -8. We write the -8 in braces, which is set notation. We refer to the -8 as the solution or the solution set. If we want to determine if -8 is the solution, we can check by substituting the -8 in for each x in the equation. We would have 3 times -8 plus 7. Does that equal to 2 times -8, subtract 1. 3 times -8 would give us -24 plus 7. -24 plus 7 would give us -17. On the other side, we would have 2 times -8, which is -16. Subtract 1. -16 subtract 1 gives us a -17. Since we get the same number on the left as we do on the right when we substitute -8 in the original equation for each x, we know that -8 checks as the solution for the equation. We've talked about what we mean by solve and check. Is it important for us to recognize that an equation is a linear equation in one variable? The answer is yes, it is. As we complete our study of algebra, we will learn to solve many different types of equations. We will learn different steps and different rules for each type. When we begin to solve an equation, it is very important that we recognize which type of equation we are trying to solve, so we'll know which rules and which steps to follow. Let's look at this problem again. (3x plus 7 equals 2x minus 1). This equation is a linear equation. The power of the variable in each variable term helps determine the type of equation. What is the power of the variable x in each of the variable terms for this problem? There is no written exponent, so what is the power assumed to be? The exponent is assumed to be a 1, which means that the variable is raised to the first power. A linear equation is an equation in which the power of the variable is 1. A linear equation in one variable is a linear equation in which there is only one variable. We've discussed what we mean by solve and check. We've discussed what we mean by a linear equation in one variable. When we recognize that an equation is a linear equation in one variable, what that should tell us to do is to get the x, if it is the one variable, by itself on one side of the equation. To do that, it's like a game. We follow certain steps and certain rules until we isolate the x. So what are the steps and the rules? Steps for solving a linear equation in one variable. First, we will remove all parentheses or grouping symbols. Second, if there are any fractional coefficients, we will multiply each term by the LCD to clear fractional coefficients. Now, sometimes we would prefer to remove the fractional coefficients and then remove the grouping symbols. That's really your choice. I think it is much safer to remove the grouping symbols and then the fractions. Next, we will combine like terms on each side of the equal. We will then get all x terms on one side, and we will get all constants on the other side. We will remove the coefficient of the x term, and then we should have an equivalent equation. From the equivalent equation, we should be able to determine what the solution is. But first, we check to see if the proposed solution is indeed a solution for the equation we are solving. If the solution checks, then we write the solution set. We now know the steps and rules, so we're ready to solve some equations. This is a list of all the equations I'm going to solve in this lesson. I have grouped these problems and color-coded them so that if you do not have time to view the whole tape, you can view one section, and then the next time you view the tape, hopefully it will not be too difficult to fast forward to the section you want to view. Before each set of problems there is a blank screen and then a list of the problems worked in that section of the lesson. For example, there is a red screen, then a list of these problems. As I work each problem, you will notice that there is a red rectangle at the top of the page where I am working. Next, you will see a blue screen and a list of the blue problems, and each of these problems will have a blue rectangle at the top of the page. Each section is formatted in this way. A black screen, a list of these problems, black rectangles at the top of the page, a green screen, a list of these problems, and green rectangles at the top of the page. I shall begin with the red problems. If you would like to begin with a different set of problems, fast forward to the set you would like to view. Variables on both sides of the equation and special solutions. Here are the equations I shall solve in the first set of problems. Problem number 1, solve and check. First, I note that it is a linear equation. The power on the x would be 1 here and 1 there. That tells me that what I want to do is to get x by itself on one side of the equation. I first look for parentheses or grouping symbols, and there are none. I then look for fractional coefficients, and there are none. I look for like terms on the same side of the equation, and there are none. So I will begin by getting the x terms on one side. I may choose to move the 5x or the 7x. Usually I choose to move the term with the smaller coefficient. Since the 5 is smaller than the 7, I will move the 5x. To move the 5x, since it has been added to the left side of the equation, I will subtract 5x from both sides of the equation. 5x subtract 5x gives me 0x. I did nothing with the minus 5. 7x subtract 5x gives me 2x. Plus 2. Please notice how I lined up my like terms. Now usually we do not write the 0x. We do not write it because 0 times x is 0. And 0 subtract 5 is simply a negative 5. So usually we just write a negative 5 there. So I have negative 5 equals 2x plus 2. Next, I want to get my constants on the other side of the equation. Since my x term is on the right, I want my constants on the left. My negative 5 is already on the left, so I need to move my 2. Since my 2 has been added, I will subtract 2 from both sides of the equation. Negative 5 subtract 2 gives me negative 7 equals, I did nothing with the 2x, 2 subtract 2 is 0. Next, I need to remove the x coefficient. The x coefficient is 2. Since the 2 has been multiplied times the x, to undo multiplying x by 2, I will divide both sides of the equation by 2. If you prefer, you may multiply both sides of the equation by 1/2 instead of dividing both sides by 2. The result is -7/2 equals 2 divided by 2 is 1x. What I have here is the equivalent equation. I think the solution is -7/2. Let's check and see if it is. To check, I replace each x with the -7/2. Instead of having 5 times x, I will have 5 times -7/2. Subtract 5. Does that equal 2? 7 times -7/2 plus 2. I need to multiply the 5 times the -7/2. I will write the 5 as 5 over 1 times the -7/2, subtract 5. Let's calculate the result on the left. A positive times a negative will give me a negative. 5 times 7 will give me 35. 1 times 2 will give me 2. And then I need to subtract 5. So let's write the 5 over 1 so that I can subtract these fractions. I need an LCD. The LCD is 2. The 35/2 already has an LCD of 2. The 5 over 1 I will need to multiply by 2 over 2. So I will have -35/2 subtract 5 times 2 is 10. 1 times 2 is 2. -35/2 subtract 10/2 gives me a -45/2. Let's see if that's what I get on the other side of the equation. First, I need to multiply the 7 times the -7/2. I will write 7 over 1 times -7/2 plus 2. Positive times a negative gives me a negative. 7 times 7 gives me 49. 1 times 2 gives me 2. And then I'm going to need to add 2 to that, so let's write the 2 as a fraction over 1. Once again, the LCD is 2. The 49/2 has a denominator of 2, so I need to multiply the 2 over 1 by 2 over 2. I have -49/2 plus 2 times 2 is 4, 1 times 2 is 2. -49/2 plus 4/2 gives me a -45/2. I get the same number on the left I do on the right. So that tells me -7/2 is the solution. So let's write the -7/2 in set notation. Problem number 2. Once again, I am to solve and check. It is a linear equation. I'll look for parentheses. There are none. I'll look for fractional coefficients. There are none. I'll look for like terms on the same side of the equation. On the left side of the equation, the -4x is like the 2x. So I may combine -4x and 2x. -4x plus 2x gives me a -2x. I did nothing with the 5. Equals, on the other side of the equation, I have -2x, subtract 6. I now want to get the x terms on the same side of the equation. Look at the coefficient of the x terms. They are the same. Usually I try to move the smaller. But in this case, since those coefficients are the same, it doesn't matter which term I move. I will choose to move the -2x. Since the 2x has been subtracted from the right side of the equation, to undo the subtraction, I will add 2x to both sides of the equation, lining my like terms up. -2x plus 2x is 0x. I will not write the 0. I've got my 5 equals -2x plus 2x is 0x. And I didn't do anything with the -6. What does that equation say? It says 5 equals negative 6. 5 does not equal negative 6. 5 equals negative 6 is a false statement. When you solve a linear equation and you follow the steps and rules, and in the process you eliminate all of your x terms, when you are left with a false statement, then what that means is there is no solution for this equation. There is no number that we can replace this x with, and that x with, such that when we calculate the number on the left, it will equal the number that we calculate on the right. When there is no solution, we just write no solution, or we may use the empty set symbol to mean there is no solution. Problem number 3. Solve and check. Once again, it is a linear equation. I check for parentheses. I check for fractional coefficients. I check for like terms. I do have like terms on the right side of the equation. Let's write the 1 2/10 x plus 3. On the right side of the equation, the negative 4/10 x and the 1 6/10 x are like terms. Let's go ahead and write the 3, and let's combine the negative 4/10 x and the 1 6/10 x. To combine these like terms, I need to subtract their coefficients. So I will say 1 6/10 subtract 4/10. 6 subtract 4 is 2. Bring your decimal down. 1 subtract 0 is 1. Since the 1 6/10 is larger than the 4/10, the 1 2/10 will be positive. So when I combine minus 4/10 x and 1 6/10 x, I get 1 2/10 x. Now it's time to get the x terms on the same side of the equation. Once again, the coefficients of the x terms are the same. I will choose to move this 1 2/10 x. Since it has been added to the right side of the equation, I will subtract it from both sides of the equation. 1 2/10 x subtract 1 2/10 x is 0x. I've done nothing with the 3. On the other side of the equation, I have the 3. 1 2/10 x subtract 1 2/10 x gives me 0x. What do I have? Once again, I have eliminated all of my x terms, but this time, this equation says 3 equals 3. 3 equals 3 is a true statement. When we solve a linear equation and we eliminate all the x terms, and the equation that we are left with is a true statement, that means that the solution of this equation is all real numbers. That means that if I chose a 5 and I substituted 5 in for this x, 5 in for this x, and 5 in for this x, when I calculated the number on the left, it would equal to the number that I calculate on the right. 5 would check. 6 would also check. 7 would check. 8 would check. 1/2 would check. Any real number would be a solution for this equation. Well, obviously we don't have time to check all the real numbers, so we will not check this problem. Problem number 4, solve and check. I would like for you to work this problem. After you have solved and checked the problem, I shall give you the correct solution and shall work and check the problem so you can check your work. Now please pause the tape and work the problem. How did you do? Did you find that -3/2 was the solution for this equation? If so, you may want to fast forward to the blue section of problems. If not, you may follow along as I solve and check this equation. To begin with, it's linear. I look for parentheses. I look for fractional coefficients. I look for like terms on the same side of the equation. On the left, I have 2x, subtract 3x. Those are like terms, so I can combine them. 2x subtract 3x is -x. I then have a -1 equals x plus 2. I now want to get the x terms on the same side of the equation. I will move the negative x because its coefficient is -1, and that is smaller than the coefficient of a positive x because its coefficient is a positive 1. To move the negative x, since it has been subtracted from the left side of the equation, I will add x to both sides of the equation. -x plus x is 0x. I am left with -1 equals x plus x is 2x plus 2. I now need to move my constant 2 to the other side of the equation. Since the 2 has been added, I will subtract 2 from both sides. -1 subtract 2 gives me -3. I did nothing with the 2x. 2 subtract 2 is 0. I now need to get rid of the coefficient of my x term. Since the x has been multiplied by 2, I will divide both sides of the equation by 2. The result is the equivalent equation, -3/2 equals 2 divided by 2 would give me 1x. Let's check. Let's substitute the -3/2 in for x in the original equation. I would have 2 times -3/2, subtract 1, subtract 3 times -3/2. Does that equal to x, which I think is -3/2 plus 2? Let's work with the left side. I need to multiply 2 times -3/2, so I will say 2 over 1 times -3/2, subtract 1. I need to multiply the -3 times -3/2, so I'll write my minus sign. 3 over 1 times -3 over 2. When I multiply, the positive times the negative is a negative. The 2's will cancel. I am left with 3 over 1, which is 3. I have my -1. When I multiply my -3 over 1 times -3/2, the negative times the negative is a positive. 3 times 3 is 9. 1 times 2 is 2. Let's combine the -3 and the -1. -3 subtract 1 gives me -4. I'm going to have to add that to this 9/2, so let's go ahead and write the -4 as a negative and then 4 over 1 plus 9/2. The LCD is 2. I will multiply the -4 over 1 by 2 over 2. Get a negative. 4 times 2 is 8. 1 times 2 is 2. I want to add to that the 9/2. -8/2 plus 9/2 gives me a positive 1/2. Let's see if I get positive 1/2 on the right side. On the right side, I have the -3/2 plus 2. Let's write the 2 as 2 over 1. The LCD is 2. I will multiply the 2 over 1 by 2 over 2. So I will have -3/2 plus 2 times 2 is 4. 1 times 2 is 2. -3/2 plus 4/2 gives me 1/2. I get the same number on the left as I do on the right. That tells me that -3/2 checks. So let's write it as a solution set. That completes this section. Now let's move to the blue set of problems. Removing grouping symbols. Here are the equations I shall solve in this set of problems. Problem number 1, solve and check. It is a linear equation, so I want to follow my steps to isolate x. First, I will remove the parentheses. To do that, I will distribute this 5. 5 times x is 5x. 5 times 2 gives me 10. And then I have a negative 3 equals minus 2x. When I have a negative in front of the parenthesis, I can remove the parenthesis by changing the sign of each of these terms, or I may think negative 1 times x is negative x, negative 1 times negative 7 is positive 7. I now need to combine like terms since I don't have any fractional coefficients. I have 5x, 10 subtract 3 will give me 7, equals minus 2x subtract 1x gives me a negative 3x plus 7. I'm to the point where I need to get all the x terms on one side, and then I will get all the constants on the other side. To get all the x terms on one side, I will choose to move the negative 3x since its coefficient is smaller than the positive 5x. Since the negative 3x represents subtracting 3x from the right side of the equation, I will add 3x to both sides of the equation. 5x plus 3x gives me 8x plus 7 equals the minus 3x plus 3x is 0, and then I have my 7. I now want to move this 7 to the right side of the equation. Since the 7 has been added, I will subtract 7 from both sides of the equation. I get 8x, 7 subtract 7 is 0, equals 7 subtract 7 is 0 on the right side also. I need to write the 0 because that's the only term on the right side. I now want to get rid of the coefficient of x. Since x has been multiplied by 8, I will divide both sides of the equation by 8. 8x divided by 8 will give me 1x, and 0 divided by 8 will give me 0. So the equivalent equation here is x equals 0. Now I need to check to see if 0 is the solution. So in the original equation, I will replace each x with 0. So I will have 5 parentheses 0 plus 2 subtract 3. Does that equal to minus 2 times 0 subtract parentheses 0 subtract 7. On the left side, let's work what's in parentheses. We'll have 5 parentheses 0 plus 2 is 2 subtract 3. 5 times 2 is 10. 10 subtract 3 is 7. Let's see if we get 7 on the right side. Let's write the negative 2 times 0 subtract. In parentheses we have 0 subtract 7, which is a negative 7. Negative 2 times 0 is 0, minus a negative 7 is a plus 7. 0 plus 7 is 7. Since 7 equals 7, that tells me that 0 is the solution for this equation. So let's write it as a solution set. Problem number 2, solve and check. It is a linear equation. I want to isolate the x. I will first remove the parentheses. I will write the 3 and 5/10 x. To remove this parenthesis, I need to distribute the negative 1 and 5/10. When I multiply 1 and 5/10 times 2x, a negative times a positive is a negative. And to get the coefficient, I need to multiply 1 5/10 times 2. 2 times 5 is 10. 2 times 1 is 2 plus 1 is 3. There is one digit behind the decimal, so I will come across one place. The result is 3 0/0, which is just 3. So when I distribute negative 1 5/10 to the 2x, I get minus 3x. Negative 1 5/10 distributed to the negative 3. Let's say a negative times a negative is a positive. And let's figure out what 3 times 1 5/10 is. 3 times 5 is 15. 3 times 1 is 3 plus 1 is 4. Once again, I have one digit behind the decimal, so I will come across one place. So the result is 4 5/10 equals 9 5/10. I have no fractional coefficients. I do have like terms on the left, so let's combine the like terms on the left. I need to say 3 5/10x, subtract 3x. To get the coefficient, I take 3 5/10, I subtract 3 from it. The decimal is understood to be behind the 3. 5 subtract 0 is 5. Bring down the decimal. 3 subtract 3 is 0. So the coefficient that I get when I say 3 5/10x subtract 3x is 5/10. And 5/10 then is the coefficient of x. I have plus 4 5/10 equals 9 5/10. Now I only have one x term. It is on the left side of the equation, so I want the constants on the right side. So I will move the 4 5/10. The 4 5/10 has been added. To undo the addition, I will subtract 4 5/10 from both sides of the equation. I have done nothing with the 5/10x. 4 5/10 subtract 4 5/10 is 0. On the right side, 9 5/10 subtract 4 5/10. 5 subtract 5 is 0. Bring down the decimal. 9 subtract 4 is 5. So I get 5/10x equals, and 5 0/10 is the same as 5. Next, I need to divide both sides by the 5/10 because it is the coefficient of x. 5/10x divided by 5/10 is 1x. And on the right, I need to divide 5/10 into 5. The decimal in the 5 is understood to be behind it. In order to divide, I move this decimal one place, which means I have to move this decimal one place, so I will write my 0 and move my decimal. I am now dividing 5 into 50. 5 goes into 5 once, and 5 goes into 0 times. So the result is 10. My equivalent equation is x equals 10, and I need to check to see if this is the solution for this equation. So let's substitute 10 in for each x in the original equation. So I will have 3 5/10 times 10 minus 1 5/10. I will use a bracket. 2 times 10 minus 3. And the question is, does that equal to 9 5/10? Let's work what's in brackets first. I have 2 times 10 is 20. Subtract 3. Let's write the 3 5/10 times 10. Subtract 1 5/10. The 20 subtract 3 is 17. Now, let's multiply the 3 5/10 times 10. 0 times 5, 0 times 3, 1 times 5, 1 times 3. I'll have 0, 5, 3. There is one digit behind the decimal, so I will come across one place. 3 5/10 times 10 is 35. Subtract Let's take the 1 5/10 and multiply it by 17. 7 times 5 is 35. 7 times 1 is 7, plus 3 is 10. 1 times 5 is 5. 1 times 1 is 1. When I add, I get 5, 5, 1, and 1 is 2. There is one digit behind the decimal, so I will come across one place. The result of multiplying 1 5/10 times 17 is 25 5/10. On the left side, I have 35 subtract 25 5/10. To subtract, I cannot take the 5 from the 0. I will borrow. When I borrow 1 from 5, it leaves me with 4, and I will add 10. 10 subtract 5 is 5. I will bring down the 1. I cannot take 5 from 4. I will borrow, leaving me with 2, adding 10. 14 subtract 5 is 9. 2 subtract 2 is 0. So 35 subtract 25 5/10 gives me 9 5/10 on the left, and the number on the right is also 9 5/10. So we know that 10 is the solution. So we will write 10 as a solution set. Problem number 3. I would like for you to work this problem. After you have solved and checked the problem, I shall give you the correct solution and shall work and check the problem so you can check your work. Now please pause the tape and work the problem. How did you do? Did you find that the solution is all real numbers? If so, you may want to fast forward to the next section of problems. If not, you may follow along as I solve this equation. It is a linear equation. I want to get x by itself. My first step is to remove the parentheses. I will distribute the 2. 2 times 3x is 6x. 2 times negative 2 is negative 4 plus 1 equals 6x. Subtract 3. There are no fractional coefficients. Combining like terms, I have 6x minus 4 plus 1 gives me a negative 3. On the other side of the equation, I have the 6x subtract 3. I now want to get the x terms on the same side of the equation. And notice the x terms have the same coefficient. I will choose to move this 6x. Since this 6x has been added to both sides of the equation, I will subtract 6x from both sides of the equation. 6x subtract 6x is 0x. I have done nothing with the negative 3. On the right side of the equation, 6x subtract 6x is also 0x, and I still have the negative 3. The equation says negative 3 equals negative 3. This is a true statement. Since I have eliminated all of the x terms and the resulting equation is a true statement, the solution is all real numbers. And I will not check all real numbers. This completes this section. Now let's move to the black set of problems. Fractional coefficients. Here are the equations I shall solve in this set of problems. Problem number 1, solve and check. It is a linear equation. I want to follow my steps. I'll look for parentheses and there are none, but I do have fractional coefficients. To get rid of the fractional coefficients, I will multiply both sides of the equation by the LCD. The LCD of 3, 4, and 6 is 12. So I will say 12 times 2/3 x minus 1/4 equals 12 times 1/6 x plus 2. When I distribute the 12, I will say 12 over 1 times 2/3 x, and I will say a positive times a negative is a negative. 12 over 1 times 1/4 equals, on the right side of the equation, I will have 12 over 1 times 1/6 x, and 12 times 2 will give me 24. When I say 12 over 1 times 2/3, 3 goes into 3 once and into 12 4 times. I am left with 4 times 2 over 1, which is 8 times x, minus 4 goes into 4 once and into 12 3 times. I am left with 3 over 1, or 3, equals 12 over 1 times 1/6. 6 goes into 6 once and into 12 twice. I am left with 2 over 1, or 2x, plus 24. I now want to get the x terms on the same side of the equation. I will choose to move the 2x. Since the 2x has been added, I will subtract 2x from both sides of the equation. 8x subtract 2x is 6x. Subtract 3 equals 2x subtract 2x is 0x, and I am left with 24. I want my constants on the same side of the equation. I will move the negative 3. To move the negative 3, I need to add 3 to both sides of the equation. The result is 6x minus 3 plus 3 is 0 equals 24 plus 3 is 27. I now want to get rid of my x coefficient. I will do that by dividing by 6. 6x divided by 6 is x. 27 divided by 6 can be reduced. 3 goes into 27 9 times. 3 goes into 6 twice. My equivalent equation is x equals 9/2. Now let's check 9/2 in the original equation. Let's replace each x with 9/2. So I will have 2/3 times 9/2, subtract 1/4. Does that equal to 1/6 times 9/2 plus 2? On the left side, when I multiply 2/3 times 9/2, 2 goes into 2 once, 2 goes into 2 once, 3 goes into 3 once, 3 goes into 9 3 times. I'm left with 3 over 1, or 3. I need to take this 3 and I need to subtract it from 1/4, so I'll write the 3 as 3 over 1 minus 1/4. In order to subtract the 1/4 from the 3, the LCD is 4, so I will multiply the 3 over 1 by 4 over 4. 3 times 4 is 12. 1 times 4 is 4. Subtract 1/4. 12/4 subtract 1/4 gives me 11/4. On the right side, when I say 1/6 times 9/2, 3 goes into 6 twice and into 9 3 times. I am left with 1 times 3 over 2 times 2, and I want to add 2 to 3/4. The LCD is 4. I will multiply the 2 over 1 by 4 over 4. I get 3/4 plus 2 times 4 is 8. 1 times 4 is 4. 3/4 plus 8/4 is 11/4. Since I have 11/4 on the left and 11/4 on the right, I know that 9/2 checks as the solution for this equation. So I will write the 9/2 as a solution set. Problem number 2. I would like for you to work this problem. After you have solved and checked the problem, I shall give you the correct solution and shall work and check the problem so you can check your work. Now please pause the tape and work the problem. How did you do? Did you find that 10 is the solution for the equation? If so, you may want to fast forward to the green section of problems. If not, you may follow along as I solve and check this equation. It is a linear equation. I want to remove parentheses if I have parentheses, but since I do not, I want to remove the fractional coefficients. I do that by multiplying by the LCD. The LCD for 5 and 2 is 10. So I will say 10 times x over 5 plus 1 equals 10 times x over 2 minus 2. When I distribute the 10, I will have 10 over 1 times x over 5, and 10 times 1 will give me 10. On the right side, I will have 10 over 1 times x over 2, and 10 times negative 2 will give me negative 20. When I say 10 over 1 times x over 5, 5 goes into 5 once and into 10 twice. I am left with 2 times x over 1 times 1, which is just 2x, plus 10, equals, on the right side, the 2 goes into 2 once and into 10 5 times. I am left with 5 times x over 1, or 5x, minus 20. I now want to get the x terms on the same side of the equation. I will choose to move the 2x. Since the 2x has been added to the left side, I will subtract 2x from both sides of the equation. 2x subtract 2x is 0x. I did nothing with the 10. 5x subtract 2x is 3x. And I have the minus 20. I now want to move the minus 20 to the left side of the equation. Since the 20 has been subtracted from the right side of the equation, I will add 20 to both sides of the equation. 10 plus 20 is 30. I have the 3x minus 20 plus 20 will give me 0. I now need to get rid of the coefficient of x. Since x has been multiplied by 3, I will divide both sides of the equation by 3. 30 divided by 3 will give me 10. 3x divided by 3 will give me x. My equivalent equation is 10 equals x. Now let's check it. Let's go back into the original equation. Let's replace each x with 10. I will have 10 divided by 5 plus 1. Does that equal 2? 10 divided by 2 minus 2. On the left, 10 divided by 5 is 2. 2 plus 1 is 3. On the right, 10 divided by 2 is 5. 5 subtract 2 is 3. So 10 checks as the solution for this equation. Let's write 10 as the solution set. This completes this section. Now let's move to the green set of problems. fractional coefficients, and grouping symbols. Here are the equations I shall solve in this set of problems. Number 1, solve and check. It is a linear equation, so I will go through my steps. My steps say to first remove the parentheses and then to take care of the fractions. So let's remove the parentheses. 2/3 x. When I get ready to remove this parenthesis, I distribute the -1/2 to the 3x and to the -1. I will get the sign first by saying a negative times a positive is a negative. I will say 1/2 times 3/1 times x. When I distribute the -1/2 to the -1, I will say a negative times a negative is a positive. 1/2 times 1 is 1/2 equals 1/6x. So I have removed the parenthesis. Now, let's multiply through and simplify, and then I will want to get rid of the fractions. I have 2/3 x minus 1 times 3 over 2 times 1 x plus 1/2 equals 1/6 x. To get rid of my fractions, I need to multiply both sides of the equation by the LCD. The LCD of 3, 2, and 6 would be 6. So let's multiply both sides of the equation by 6. I will have 6 times 2/3 x, subtract 3/2 x plus 1/2 equals, and on the other side of the equation, I will say 6 times 1/6 x on the left, I need to distribute the 6. I will say 6 times 2/3 x, 6/1 times 2/3 x. I will say 6 times negative 3/2 x. A positive times a negative is a negative. I will say 6/1 times 3/2 x. And then I will distribute the 6 to the 1/2. A positive times a positive is a positive. I will write 6/1 times 1/2 equals. Now on the other side of the equation, I am multiplying 6 times 1/6 times x. So I will write 6/1 times 1/6 times x. Let's actually do the multiplication. 6/1 times 2/3. 3 goes into 3 once and into 6 twice. I am left with 2 times 2/1. 2 times 2 would give me the 4x minus 2 goes into 2 once and into 6 3 times. I am left with 3 times 3, which is 9, over 1, which would be 9x, plus 6/1 times 1/2. 2 goes into 2 once and into 6 3 times. I am left with 3/1, or 3, equals, and when I multiply 6/1 times 1/6, the 6's cancel. I am left with 1/1, or 1x. I have removed parentheses. I have gotten rid of my fractions. I will now combine like terms. 4x subtract 9x gives me a negative 5x plus 3 equals x. I now want to get my x's on the same side of the equation. The negative 5 is a smaller coefficient than the 1, so I will move the negative 5x. Since the 5x has been subtracted from the left side of the equation, I will add 5x to both sides of the equal. Negative 5x plus 5x is 0x. I will have 3 equals x plus 5x will give me 6x. I now need to get rid of the coefficient of x. Since the x has been multiplied by 6, I will divide both sides of the equation by 6. The resulting equivalent equation 3/6 will reduce to 1/2. 6x divided by 6 is 1x. So the equivalent equation is 1/2 equals x. Now I need to check this in the original equation. So I want to replace each x with 1/2. So I will have 2/3 times 1/2, subtract 1/2. Once again, I'm going to use brackets. I'm going to have 3 times 1/2, subtract 1. Does that equal to 1/6 times 1/2? Let's work what's in brackets first. I'll have 2/3 times 1/2, subtract 1/2. In the brackets, I will say 3 is 3/1 times 1/2, subtract 1. 2/3 times 1/2, subtract the 1/2. 3 times 1 is 3. 1 times 2 is 2. Now I want to subtract the 1 from the 3/2. I will write the 1 as 1/1. I need an LCD to subtract, so my LCD is 2, so I will multiply by 2/2. So I will have 2/3 times 1/2, subtract 1/2, times 3/2, subtract 1 times 2 over 1 times 2. Now in my brackets, I now say 3/2 subtract 2/2, which is 1/2. I am ready to multiply 2/3 times 1/2. Of course, the 2's cancel. I am left with 1/3. Subtract 1/2 times 1/2. 1 times 1 is 1. 2 times 2 is 4. To subtract these fractions, I need an LCD, which is 12. I will multiply the 1/3 by 4/4, the 1/4 by 3/3. 4 times 1 is 4. 4 times 3 is 12. Subtract 1 times 3 is 3. 4 times 3 is 12. 4 twelfths, subtract 3 twelfths, gives me 1/12 for the left side of the equation. The right side is much simpler. 1/6 times 1/2. 1 times 1 is 1. 6 times 2 is 12. So sure enough, when I check to see if 1/2 is the solution of the equation, since 1/12 is equal to 1/12, I know that 1/2 is the solution for this equation. Let's write the 1/2 as the solution set. Problem number 2. I would like for you to work this problem. After you have solved and checked the problem, I shall give you the correct solution and shall work and check the problem so you can check your work. Now please pause the tape and work the problem. Did you find that the solution is 6? If so, good for you. I will finish this tape by solving and checking this equation. It is linear. My first step is to remove the parentheses. I will say 1/2 times 2. I will go ahead and write the 2 as 2/1. I will say 1/2 times negative x. A positive times a negative is a negative. And then I will write 1/2 times x. Equals, I will say 2/3 times 2x. I will write the 2 as 2 over 1, and then I will say 2/3 times negative 15. A positive times a negative is a negative. 2/3 times 15 over 1. Simplifying my multiplication, my 2's will cancel. I am left with 1 over 1 or 1 minus 1/2 x equals 2 times 2 is 4, 3 times 1 is 3 times x minus 3 will go into 3 once and into 15 5 times. I am left with 2 times 5, which is 10 over 1 or 10. I have removed the parentheses. I now need to get rid of the fractions. To get rid of the fractions, I will multiply both sides of the equation by the LCD. The LCD of 2 and 3 is 6. So I will say 6 times 1 minus 1/2 x equals 6 times 4/3 x minus 10. Let's distribute the 6. 6 times 1 is 6. When I say 6 times a negative 1/2 x, a positive times a negative is a negative. I will write 6 over 1 times 1/2 x equals, on the right side when I distribute the 6, 6 over 1 times 4 over 3 times x, and 6 times negative 10 is negative 60. Now let's simplify the fractions. I will have 6 minus 2 goes into 2 once and into 6 3 times. I am left with 3 times 1 over 1 or 3x equals 3 goes into 3 once and into 6 twice. I am left with 2 times 4, which is 8 over 1 or 8x minus 60. I now want to get my x terms on the same side of the equation. The negative 3x has the smaller coefficient. The 3x has been subtracted from the left side of the equation, so I will add 3x to both sides of the equation. The result is 6 minus 3x plus 3x is 0x. 8x plus 3x is 11x. Subtract 60. I now want to move the negative 60 to the left side of the equation. Since the 60 has been subtracted from the right side of the equation, I will add 60 to both sides of the equation. 6 plus 60 is 66. On the right, I have 11x. Minus 60 plus 60 is 0. I now need to get rid of the coefficient of x. Since x has been multiplied by 11, I will divide both sides of the equation by 11. That will give me my equivalent equation. 66 divided by 11 is 6. 11x divided by 11 is x. My equivalent equation is 6 equals x. Now let's check the 6 in the original equation. I will replace each x with the 6. I will have 1/2 times 2 subtract 6 equals 2/3. This is a question. Does it equal 2/3 times 2 times 6 subtract 15? On the left, I have 1/2 times 2 subtract 6 is a negative 4. I'll have 1/2 times negative 4 over 1. Positive times a negative is negative. 2 goes into 2 once and into 4 twice. I am left with 1 times 2 or 2 over 1, which is 2. So on the left side of the equation, I have a negative 2. On the right side, let's work what's in the brackets first. 2 times 6 is 12. Let's subtract the 15 from the 12. 12 subtract 15 gives me a negative 3. Let's multiply 2/3 times a negative 3. Write the 3 is 3 over 1. The 3 goes into 3 once. A positive times a negative gives me a negative. I am left with 2 times 1, or 2, over 1, which is 2. On the left I have negative 2. On the right I have negative 2. So when x is equal to 6, we know that that is the correct solution. Let's write the 6 as a solution set. That completes the solving linear equations in one variable lesson. Please rewind the tape before you return it. Thank you.